Hello and welcome to Quick Online Study today. We want to talk about trigonometry, okay? It's going to be a two-part series. The first one, we are going to talk about the identities and equations, okay? And the second part is going to really concentrate on graphs, all questions on graphs, excuse me, how to sketch trig graphs, how to transform trig graphs, okay? So look forward to that video as well. But before we get started, I want to thank everyone who has subscribed to this channel. You've been really helpful. We started from 1 subscriber, now we're at 485. Okay, so if you haven't subscribed already, please subscribe and let's hit the 500 mark. All right, so now let's delve right into it. Now, note that Cambridge will always give you some formulae under trigonometry in terms of the identities. Okay, so you will see something like sine square x plus cos square x is equal to 1. This identity will be given, and then you will also be given this identity sec square x is equal to 1 plus tan square x. So you don't have to memorize this one, it would always be given. All right, then the last identity that Cambridge is going to give you is the cosec square x is definitely equals 1 plus cot square x. All right, so these identities will be given, these three will be given. Now there is this particular identity that you need to know. For example, if you see cosec x, it basically means 1 over sine x. Okay, it's the reciprocal. And then you could also be given sec. You should also know that it's 1 over cos x. All right, so making 5. Okay, but these three will be given. You have to keep these two in mind. Okay, and then basically from there you should be fine in terms of any other kind of identity that you will need, because basically you should be fine at this stage. So let's start with our very first question. Okay, let me clear this thing from here. Of course, we'll be coming back to it as and when we need it. Okay, so the first question says that solve the equation cosec square plus 2 cot square is equal to 2 cot plus 9. Okay, and then they have told you that theta, the angle in question, is from negative pi on 2 to pi on 2. I'll really explain this thing for you to really understand it later on. But right now, we just have to solve this equation, okay? Now, you see that the angle in question is in radians. So the first thing you want to do is to change your calculator, the angular unit to radians. That's the first thing you need to do. If not, you'll be working in degrees. Meanwhile, the question is in radians, and you'll be marked down, okay? All right. So you see, we have cot here, we have cot there as well. So what we really want to do is to change this cosec to cot. Remember, we said that cosec square theta is equal to 1 plus cot square theta. This will be given to you, so don't memorize it. You don't need to memorize this guy. All right, so let's clean it. All right, you don't need to memorize it, but of course, if you know it, it's great. Just that you don't have to memorize it. Okay, so I'll write 1 plus cot square theta. Then we have plus 2 cot square theta is equal to 2 cot theta plus 9. Sure, if I am to simplify this, I'm going to have 3 cot square theta plus, no, actually negative, okay, because I'm going to bring this guy right here. So minus 2 cot theta, all right, then we have minus 9 and then plus 1 giving us 0. So we have 3 cot square theta minus 2 cot theta minus 8 is equal to 0. Okay, so at this stage, I'm just going to use my calculator to solve this, because I believe that all of us can actually do a quadratic, okay? And then we are not here to really solve a quadratic, so I'm just going to put it on calculator to give me the answers. Okay, so calculator says that I'll get cot theta is equal to 2, or cot theta is equal to negative 4 over 3. Okay, at least that's what the calculator is saying. All right, so this is what I have. Now, this is what I want you to do. Take your time. You will not see any cot on the calculator, But we know that cot theta is basically 1 over tan theta. Okay, so that means that tan theta is also 1 over cot theta. So all the answers will actually change. So you can write tan theta is equal to half. Okay, it will flip since it's the reciprocal. And then this, let me also write tan theta. Tan theta here will become negative 3 over 4. Okay, so this is what you should keep in mind, right? Because actually cot is called cotangent, so it's coming from tangent. All right. So the next thing that you want to do is to find this particular angle by looking for the tan inverse of half. Make sure that your calculator is in radians. Very, very important. So tan inverse of 0.5 is going to give you theta is 0.4643 SF. Okay, and then for this one you have tan inverse of negative 3 over 4, and that should give us tan inverse of negative 3 over 4, giving us negative, is it negative 3? Oh, tan inverse of negative 3 over 4, that gives us negative 0.643 SF. Okay, now remember that they said we should, let me squeeze this thing in a little bit. They said we should solve within this. Okay, so what I normally do is to draw this plus sign, okay, and call it casts. All right, what cast seeks to mean is that here cos is positive, here all trig ratios are positive, here sine is positive, here tan is positive. So if I take, and remember that they said I should work from negative pi on 2 to pi on 2, okay? Always, this is your zero line. Okay, so this is pi on 2. Moving in this direction is positive, and moving in that direction is negative. So that means this is negative pi on 2. All right, now, if you check the first one, okay, you got this value, which is a positive value, definitely going to be somewhere here. Okay, so you have your 0.464. When you are going to pi on 2, you hit the line here, and that is your desirable answer. It ends there. Here you got this value, negative 0.644. That means that that value is down here. Okay, so if you are also going to negative pi on 2, you hit this line here, and that's answered. That is the angle. Now I'm going to solve more complex examples using this cast method, and to help you to allocate all your desirable angles. Okay, so you conclude that therefore theta is equal to negative 0.644, and then theta is also equal to 0.464. Okay, and then you are done. This is the next question. Actually, these are a paper that came 1-3 May, June 2021. So those of you who are preparing for your October, November, I think this is a really good resource for you. And this is also, May, June 2021. Actually, I'm solving papers from 2021 all the way to, I think, 2019 or so. And I will also put the worksheet in the description down there so that you can also download it and then work alongside with me. All right. Now, this question says question 10 says we should solve this particular equation for, now this is really, really important. From here to here, your calculator must be in what? Radians. Very, very important. Okay. All right. So now, you know what cosec is 1 over sine, right? Cool. So that means you have sine alpha into bracket 1 over sine square alpha because of the square here. Okay. And then you have plus cos alpha into bracket 1 over sec square is 1 over cos square. So cos square alpha all equal to 0. Now, this cancels one of that. This also cancels one of that. That simplifies your answer to get 1 over sine alpha plus 1 over cos alpha is equal to 0. Okay, now you need to solve this guy. Well, you can solve it simultaneously, not simultaneously per se, but this is like a fraction that you are solving. So you have cos alpha plus sine alpha over sine alpha cos alpha is equal to 0, right? So you can cross multiply out, and then you have sine alpha plus cos alpha is equal to 0. Move the cos to the other side, and I'm going to move the cos because I want to get a tan. So I'm going to have sine alpha is equal to negative cos alpha. Then I'll divide both sides by what? Cos alpha. All right, I'll divide both sides by cos alpha. That gives me tan alpha is equal to negative 1. Okay, so alpha is equal to tan inverse of negative 1. Make sure your calculator is in radians because what we are working with is radians. So tan inverse of negative 1 is equal to negative pi on 4. Okay, so that is the angle. But we are not done because they said we should work from negative pi to pi, negative pi all the way to pi. Okay, so first get this plus sign cast. Okay, now if this is your 0, then this is pi on 2, right? And this is pi. And if we start from the left, okay, it does if we go this way. But if we want to go the other way, then this will be negative pi on 2, and then this will be negative pi, okay? So what they want us to do is to move from 0 to pi, okay, from 0 all the way to pi, look for all the angles there, and then we do 0 all the way to negative pi, and look for all the angles there as well, all right? So now the first angle that you got is always your acute angle. It is negative, telling you that that angle is down here, okay? So this is your pi on 4. Don't call it negative pi on 4 because once the angle is below the 0 line, it's basically negative, okay? Now, check this thing out. This is very, very important. If you look at this claim, tan alpha is negative 1, telling you that you are working in the region where tan is what? Negative. And tan is negative in these two regions, okay? Now you can use vertically opposites and say this is also pi on 4, because if this is pi on 4, it's vertically opposite here, so there's also pi on 4. Then you start to take the direction. Let's start by first considering the direction from 0 all the way to pi and see. Now from 0 all the way to pi, we hit this line here, okay, and that is the angle we need. But this is pi on 4, so what do? You do pi minus pi on 4. That will give you the angle that you want, all right? So that angle theta will be equal to pi, actually that's 3 pi on 4. We don't need calculator to do this, okay? And then the next angle that you want to do is to go this way round, okay? Going the other way from 0 to negative pi, and that hits it right at this point, and the angle that we form is just pi on 4, okay? But this angle is down there, is below the 0 line, so that angle is negative. So we have our negative pi on 4, okay? And then you are good to go. So therefore, these are your angles. Now, some of us may want to write our answers in decimals, okay? So, which is very fine. So that will be 3 pi on 4. Calculator says our answer is basically 2.36. And then this one is negative 0.785. That is if you are working in 3SF, okay? So that is how we go about it. All right, let's move on to the B part. I like questions like these very, very much. Why? Because if I'm able to show that this is true, I have scored. Okay, so show that. If you see a question that says show that, you should be happy because you will know whether you are right or wrong at the end of the day. Right. Okay, so now this is something that we can work with. So let's work with it. Use this guy to multiply here, use this guy to multiply there, and then multiply the denominators. So that's what I'm going to do. So I'm going to get cos times cos, giving me cos squared theta. Then I have 1 minus sine square theta, and I have 1 minus sine theta, sorry, all over cos theta into bracket 1 minus sine theta. I don't want to expand it now, but let's expand it, the numerator. That will give us 1 minus sine theta, negative sine theta, plus sine square theta. I believe I have done it right. Let's see. 1 times 1 is 1. 1 times this is that. This times that is this. This times that. Okay, we are good to go. It's always good to double check your calculation, okay, in this world before you make a huge mistake. All right, now this will give us, check this thing out. Very, very, very important. You see this sine square plus cos square? Yeah, that is 1. Sine square plus cos square is 1. So that means that we have 1 plus 1, okay? This extra 1, all right, comes here. This plus this is 1. Then this 1 comes here. This will give us negative 2 sine theta, right? Negative 2 sine theta over what? Cos theta into bracket 1 minus sine theta. Right. Now, the numerator will give us 2 minus 2 sine theta over cos theta into bracket 1 minus sine theta. All right. And then in the numerator, you can just factor 2 out. So you have 2 out. You have 1 minus sine theta over cos theta. Cos theta into bracket 1 minus sine theta. Now, this and that will cancel out. And now what you have is 2 over cos theta. But 1 over cos theta is sec, right? So that means our answer is basically 2 sec theta. Okay, so we have proven it. Really, really great. All right. Okay, so the next thing that you want to do, they said solve this equation. Now, they said enhance. This means that whatever you are going to do in part II is related to I. Okay, now go back, check it out. What you have here is cos 3 theta, this cos theta, this 1 minus sine 3 theta, this 1 minus sine theta, this 1 minus sine theta, 1 minus 3. Everything is the same. That is the reason why they said that enhance, solve it. Okay, so that means that all that you have over here is actually 2 sec theta. All right, but be careful. It's not just 2 sec theta, it's 2 sec 3 theta. Because the angle here has now changed to what? 3 theta, okay? Is now equal to 4. All right, then you can divide through by what? 2, giving you this. Okay, now you know that sec is 1 over what? Cos, right? Cos theta. No, actually cos 3 theta, not just cos theta. Cos 3 theta is equal to 2, right? So you can also say that cos 3 theta is actually equal to half. And then you have your 3 theta is equal to cos inverse of half. Okay, now this will give you, hold on, let's go back. You see, this says we should change our calculator to what? Degrees, not radians anymore. So let's change it back to degrees. So I've changed mine to degrees, change yours to degrees. Then we look for cos inverse, okay, of 0.5, which is 60. Okay, now there are so many angles that could be true. But hold on, come and use the cast method, okay, to help you out. I really like to use this cast method because it really helps. I'm not saying that's the only way out there, but what I'm trying to say is that there could be a lot of things. Before we actually use this cast method, check this thing out. What we are working with is from 0 all the way to 180, right? But our angle is not theta, but rather 3 theta. So multiply through by 3, giving you 0, 3 theta, all the way to 180 times 3 is 540. Okay, so this is the new parameter that you are working with, not the 0 to 180, because it is not just theta, it's 3 theta. So always, if the theta changes, you must change the parameter. Okay, now you have your casts here nicely, CAST. All right, now you have 0. Let's calibrate it all the way to 540. So this is 0, this is 90, 180, 270, this is 300, actually 360. All right, now 360 plus 90 will give us 450, and then 450 plus 90, that will give us 540. So we end 540 here. So you see the number of rounds that we are going to go. You hold on, I'll teach you all these tricks very soon. We got the first angle to be what, 60, right? So that angle is here 60. But ask yourself, this is telling you that cos of the angle is actually positive because this is a positive half. Okay, so that means that cos is going to be positive in 2 quadrants. The A, where all are positive, and then this C quadrants here as well. All right, so the angle that the acute angle is always going to be 60 because that's what we found. All right, so but first we have to go round it in the clockwise direction because we don't have any negative indication here. Okay, so now let's start with the first direction. We hit the 60, so that's the first angle we write. Okay, so let's polish this thing a little bit. 3 theta is equal to 60. Okay, let's look for the other angles. Then you go this way to hit it here. So if this happens to be 60, if here is 60, then that means that all that we found is about 300, right? Good, so we have 300. Okay, but we don't have to end, we have to continue going. Why? Because we have to go until we hit 540. So let's go again. We will go 1 complete revolution. This thing continues to reach here as 300, right? So if we are going to 340, we hit another one here. But that is 360 plus the 60 that we just found, okay? Because we have moved a step further, and that is 360 plus 60, 420. Okay, then let's go again. All right, we are still going. From here, let's continue and see if we hit anything, any line again before the 540. And then you reach here, we don't see this line again. Okay, so that means that we got 3 answers. The first one was we came to 60, cool. And then we were continue our journey. We hit this line again, 300. We continue the journey, hit it again, making 420. Now they want you to really find what theta, because this is solve the solution. So you're looking for theta. So now divide everything by 3. So theta will give you 20, 100, and then 140, right? 420 divided by 3, that is 140. Good. So these are the 3 angles that you are looking for, right? Okay, let's move on then. Question number 9. Now this question is from paper 1 May June, okay, 2021. It says that first we should factorize this, write this in this form. Cool, right? So if we take the first 2, we can factor out 3y, and then we have 2x plus 1. And then we take this and that, we can factor out what's 2, right? So we have 2x plus 1. So our final answer is 3y plus 2, and then 2x plus 1. This is really easy. And look at it. They say hence. So that means that this is dependent on that. So basically, they want you to solve this equation. Compare something here. You have your sine theta, cos theta. That's the x and y you are seeing. You have cos theta, that's the y. You have sine theta, that's the x. You have your 2, everything is there. Okay, that's why they said, and hence solve this. Also, you must ensure that your calculator is in degrees, because the accuracy they want you to work in is actually in degrees. Okay, so this actually factorizes to 3. The y, this is x and y, so y is cos. So you have 3 cos theta plus 2, all right? And then you have another one, 2, x is sine, so 2 sine theta plus 1. Plus 2 is equal to 0. Wait, hold on, no plus 2. No plus 2, because everything here, there are how many terms? we got 1, 2, 3, 4, and we have 1, 2, 3, 4. So everything factorizes like this. Okay, so what we now do is that we have 3 cos theta plus 2 is equal to 0, okay, or 2 sine theta plus 1 is equal to 0, giving us cos theta is equal to negative 2 over 3, or sine theta is equal to negative half. Right, good. So that means that theta is equal to cos inverse of negative 2 over 3, or theta is equal to sine inverse of negative half. Make sure your calculator is in degrees. Don't keep it in radians because we are not working in radians. Okay, negative 3 over 2 over 3, that will give us theta is equal to 131.8. Okay, I'm going to just keep it to 1 decimal place. And then this one, so let me divide this thing here. This will give us sine inverse. We'll use the cast method very soon to get all the angles there. But first, we need to get our acute angles. And this is negative 30. So now, hold on. Let's start to work on this cos thing, okay? If you look at the angle we have, is theta here, okay? And they have theta here, so we don't have to adjust it. We work with it like that. So I'm just going to draw the cast, small one here, C-A-S-T. If you look at what we got here, cos theta is negative, okay? Because cos theta is giving us a negative value, and cos is going to be negative in 2 quadrants. In this quadrant, and then in that quadrant, okay? And the angle that you always find is the first angle. So from here all the way to here is at 131.8. So we can even look for this small angle here, because it's very, very necessary. So let's look for it. So we have 180 minus 131.8, and that is 48.2. So the angle is 48.2. That angle, it mixed with the x-axis, is the same angle here. So the angle here is 48.2 as well. Okay, so I'm just going to erase this guy here. Now, if we put our calibrations on this 0, this 90, this 180, this 270, and we are back to 360. So going round, we hit the line here. That's our first angle. Then if we continue, we hit the second one here. And that is after 180, we just have to add 48.2. So if you have 180 plus 48.2, you will get 228.2. Okay, so that degrees, of course, put the degree sign there. That is the second angle. Okay, within 360, you are going to make 2 angles. Now, let's come to the sine. We do a cast here. All right, and then we calibrate it 90, 180, 270, and then 360. All right, now we are told that the angle, the first angle we found was what? A negative angle. That means that it's down here. It's 30 degrees. Now, ask yourself, they are telling us that sine is what? It's negative, because sine theta is giving us a negative value. So sine is negative in 2 quadrants. It's negative in this particular quadrant, the C quadrant, because that place only cos is positive. And sine is also negative in the tan quadrant, okay? So that means that it's also negative right here. Okay, so the angle that I mix with this is also 30. All right, cool. So now we are going to, move round within 360. So we start from the 0 line. Okay, let's use this red. We start from the 0 line. We go all this way. We hit this one first. Okay, so that's beyond 180. Okay, so that means that we are looking at 180 plus the extra 30 we have down here. So 180 plus 30 will give us 210. So theta is actually 210. And then if we continue, okay, let's continue. We move all this way. We hit another one here. That is almost to the 360, so 30 degrees less. That means that we are looking at 330, right? Good. So these are the 2 angles that we have. Therefore, if we're concluding, remember that we can't work with a negative angle. So this negative angle here is not part of our answer, right? It's moving from 0 all the way to 360. So our answers will be therefore, okay, the one from the cos is giving us theta equals 131.80 and then 228.2 degrees, like that. And then the one from the sine is giving us 210 degrees and then 330 degrees. So that's how we solve a question like this. Okay, now it says the B part, solve this particular equation. Quite interesting, isn't it? First, this is what I will tell you. If you have 1 over 2 sec into bracket 2 theta plus pi on 4 is equal to 1 over root 3. First, I'll multiply through by 2. So I have sec 2 theta plus pi on 4 is equal to 2 root 3. Okay, 2 over root 3. All right. Then you know sec is the same as cos. So if I write, actually sec is the same as 1 over cos. So if I write cos into bracket 2 theta plus pi on 4, this whole thing will flip and it will become root 3 over 2, okay? Because everything turns like that. All right. And then we need to do a little bit of transformation because they gave us this, okay? Of course, we need to work in radians because they say it's in radians. So before we do anything, change the calculator to radians. So I'm changing mine to radians. Okay, it's done. Now, you see, this is not just theta. This comes with 2 theta plus pi on 4, right? So we need to transform this particular thing. So first, we need to multiply through by theta, by 2, right? So you have negative 2 pi less than 2 theta, less than what? 2 pi, right? Then we also need to add what? 4 pi to everything. So we have negative 2 theta plus pi on 4, sorry. And then 2 theta plus pi on 4. And then 2 theta plus pi on 4. All right, so let's simplify it. Negative 2 pi plus 1 over 4 pi, okay, pi on 4. That will give us negative 7 pi on 4, which is basically what? I like to write it down here so I know what I'm dealing with. We can just say 50, something like that. And then we have our 2 pi plus this guy. Then let's work with 2 pi plus pi on 4. That gives us 9 pi on 4. So that is like 7.07, something like that. Okay, so now that we have transformed it, I'm just going to delete these ones. We don't need it. Okay, and then I'll push it up so that we can look on it and then work. So always keep in mind that, let me use this guy too. Keep in mind that if you need to transform, then you must indeed transform it. Okay, let me put it maybe right here. Squeeze it small, become smaller, we can manage it. Good. All right, so we'll come back to it very soon. So we have 2 theta plus pi on 4 is equal to cos inverse of root 3 over 2, right? And what would that give us? So make sure it's in radians. All right, so cos inverse of root 3 over 2 will give us pi on 6, okay? So pi on 6. All right, now what you want to do is that take a look at this guy. Cos of whatever is in here is giving us a positive. So let's get our cast. C-A-S-T. Cos is positive. That means that that cos must be in this region or in that region, because the A means all are positive, the C means only cos is positive. Now let's calibrate it. We have a 0, This is pi on 2. This is pi, right? And then pi on 2 plus pi, pi plus pi on 2. I want to get the other one. That will give us 3 pi on 2, and then this will give us 2 pi, right? Good. And then you see, basically what I am doing is that I'm using the positive direction first. It goes all the way to 9 pi on 4, and that's like 7 point something, but 2 pi is like 6 point something, so we haven't ended. But if we add 90, okay, that's pi on 2 to 2 pi, I think it will be more than what we are looking for, plus pi, what is it, pi on 2. Actually, that is way more. So we know, because that's like 5 pi on 2, which is 7.85. And then, but we are ending right here. Okay, so we can just hold on a little bit. And we know that our argument comes all the way to here, maybe ends here. Okay, we go round, we end here. We don't go all the way to this value. Okay, and then we also need to look at the negative part, okay, this thing. So we have to calibrate that as well. So this will be negative pi on 2. This will be negative pi. This will be negative 3 pi on 2. And then this will be negative 2 pi. But it doesn't even reach negative 2 pi, because it's not like negative 8 pi on 4 that will give you 2 pi. So that's somewhere here. It doesn't also reach there. Anyways. All right, so let's actually start with a positive direction. I like to work with the positive direction first, and then I'll come back to negative direction. The first angle we got was pi on 6, so this is pi on 6. Okay, so we're actually going to go all the way up to 7.07, or all the way up to 9 pi on 4. Okay, that's more than 2 pi. All right, more than 360. Okay, so the first one gave us this, which we have written it. The next one we will go all the way, we hit it here. Okay, but if this is pi on 6, then that's also pi on 6. So that's like 2 pi minus pi on 6. All right, so you get that value. So 2 pi minus pi on 6. That should give us 11 pi on 6. Okay, so that's it. Now, if you want to go another way around, now check it out. You have to go a complete circle here and then continue. But you will not hit anything until you get to where it's ending. All right, so it ends there basically. Now, the next thing that you want to do is to go the negative direction. Okay, this way round. So that one, as soon as we do this, we hit our first value, which is negative pi on 6. Okay, then we go again. So we go all this way up to here. Okay, and then we hit again. But what we really have here is pi on 6 less than that. So it's actually the other way around too. So you can do negative 2 pi minus that. So basically we are looking at negative 11 pi on 6. Okay, so this is what we have. So now we are about to finalize everything. So we are going to move the pi on 4 to the other side. It's going to subtract from every single observation. Okay, so we have 2 pi is equal to, now let's do pi on 6 minus pi on 4, pi on 6. So pi on 6 minus pi on 4, that will give us negative pi on 12. Then the next one is 11 pi. Oh, I wanted to press pi and I pressed the percentage sign. Can you imagine? 11 pi on 6 minus pi on 4, and that will give us 19 pi on 12. Okay, and then the next one is negative pi on 6 minus pi on 4, yeah, and that will give us negative 5 pi on 12. Finally, we have negative 11 pi on 6 minus pi on 4, and that will give us 25, negative 25 pi on 12. Okay, so finally you divide through by what? 2, and then that means we have negative pi on 24, 19 pi on 24, negative 5 pi on 24, and then negative 25 pi on 24. Okay, so this is how we basically go about it. Of course, you can arrange it well. Okay, put all negatives first before you put a positive, and you are good to go. All right, so this is how you kind of go about it. All right, I hope it's not confusing. All right, okay, let's solve this particular question. I think this was a 2021 February March paper 2-1. Right, so that question says that we should show. Okay, I like the show questions. So we have, tan is the same as sine over cos. So you have sine x into bracket sine x cos x plus cos x, right? So this will give you sine square x over cos x plus cos x. I'll do it over 1, okay? So I'll just do this times that over this time that. Okay, so that will give me sine square x plus cos square x over cos x. Now sine square plus cos square, that's 1. So you have 1 over cos x giving you sec x, and you have your 3 marks. Really, really cool. Like I said, I like the show. Now they said that solve this equation. Okay, hence it means it has something to do with this. But it's in what? Radians. Okay, be careful. Radians, be careful. All right, so first change all your calculators to radians. Okay, mine is still in radians. Cool. All right, so basically sine tan cos will give us sec. That's what we just proved. Sine tan cos gives sec. Okay, but be careful of the angle there. It's not just sec x, it's sec theta over 2. Okay, that is rather equal to 4. All right, so what you really want to do is to write it in the form cos, because we know sec is 1 over cos. So cos theta over 2 is equal to 1 over 4. All right, everything flips. And then come back, modify this accuracy they gave. Okay, modify it. They want you to work with this, but we are working with pi on 2. So that means it's not pi on 2, theta on 2. So divide everything by 2. This is still 0. This will give you theta on 2, and this will give you 2 pi. So what we are really working with is from 0 to 2 pi. So we got to clean this guy. It's a trick thing that Cambridge normally does. So be careful and look out for this. And let's push it up here. Cool. Now, cos, let's find the angle. Cos theta on 2 is going to be cos inverse of 1 over 4. So cos inverse of 1 over 4, ladies and gentlemen, that gives us 1.318, something like that. Okay, excuse me. Okay, I can even make it for the small places. Along the way, I'll change it. Okay, so this is what I have. But you see, be careful, because this is not just one angle. It could be 2 angles within 2 pi, right? So just go and do the cast, and then pay attention to this one. Cos of that angle gave you a positive number, 1 over 4. So cos is positive in 2 regions, here and there. And then the angle we found was 1.3181. And then this same thing is also 1.3181. Always the angle that it makes with the x is the same. Let's calibrate it from 0 to 2 pi. So we have our 0, pi on 2, pi, 3 pi on 2, and then 2 pi. If we are going 360, okay, we hit it first one here. This is the angle that we got. The next one will be moving all the way till we hit it here. We don't know that value, but we can just do 2 pi minus that 1 point something something. So 2 pi minus 1.3181, that gives us 4.9651, correct to 4 decimal places. Okay, 4.9651, good. So that's it. Now the theta, I'll just multiply everything by 2 because I want to find theta. So that means I have, in fact, since I have this particular one ready on the calculator, let me multiply that by 2. That would give me 9.9301, and then I'll do 1.3181 times 2, giving me 2.6362. All right, but you know Cambridge likes in 3 decimal places, 3 significant figures. So I'll just write my final answer as this, and then as this. So I'm done right here. All right, so this is how I would want to solve this particular problem. February is actually February, March 2021, paper 1-2. Okay, so that's how it should have been solved. And if you do that, you have 3 plus 4 giving you 7 marks, right? And then there is this particular last one that we do that will give you about 10 marks, okay? Okay, so let's do it. So you are told that cot is actually equal to this. Hey, they are deceiving you. But before you even try, you know you can change this because you have, this is y, but actually it's from the y they have actually added what 38 to it. So transform it, okay? Add 38 to all sides. So you have 0 plus 38 is equal to y plus 38. Then you have 360, sorry, plus 38. So this will be 38 degrees, and you have y plus 38. And then, is that not 398 or something like that? 360 plus 38. Yeah, 398. Okay, so actually we have to clean this one. It's not important. So what you really want to work with is this. That's what you are working with. Okay, keep in mind that Cambridge will trick you. They normally do this. All right, now cot, right? Cot is the same as tan, 1 over tan. So we can do tan y plus 38 is equal to, then this one will flip. All right, so you have tan you have y plus 38 is equal to tan inverse of 1 over root 3. You don't have to rationalize this thing at all. No, just put it on the calculator. So tan inverse of 1 over, and hold on. I just made a mistake. Not like made a mistake. I nearly made it. You see, these are in degrees. And my calculator is in radians. Okay, so let me change it to degrees. Hey, be careful, my friends. Be really, really careful. This thing, it happens to me all the time. So I hope that it doesn't happen to you in the exam. Because the thing is, I am not writing an exam. You are. Okay, so if I make a mistake, it's not a big deal. But if you make a mistake, it's a big deal. Right, so tan inverse of this is 30 degrees. But there could be more angles than 30 degrees. So hold on. Let's go and do the cast. C-A-S-T. Tan is positive in 2 regions. This region and that region. Okay, so the angle it makes with the 30 degrees is, with the x-axis is 30 degrees. Okay, or you can say it's vertically opposite, which is true. But I mean, now we are moving from, how do I call it? From 38 all the way to here, right? So if this is 0, this will be 90. This will be 180, right? From 180, we move on to 270 to 360, to 450 to 5. Oh, no, we don't have to go to all the way 540. We don't even get to 450, right? Because the highest value, oh, sorry. I thought I was having a black. The highest value is almost 400, okay? Okay, so now let's start with our movement. If we start from here, we first hit 30, right? Okay, and then we continue, we hit 180 plus 30, which is 210. All right, and then we continue. So we make our 360 complete, and then we continue. Oh, We make our 360 complete here, but we continue. We hit the line again here, and that is 360 plus 30, and that's 390. Okay, so we end here. We don't want to go again because anything we get will be more than 398. Okay, all right, and then of course this is y plus 38. So move the 38 to the other side. This will give us negative 8, and then 210 minus 38 will give us 172, and then we have 390 minus 38, that will give us 352, right? Okay, but what are we working with? Look at this. Our angle is from 38 all the way to 398. So that means this negative 8 is not true. So therefore, y is equal to 172 degrees and then 352 degrees, because these angles are within the boundaries that we are working with. Okay, cool. All right, so let's solve this question. Maybe probably will be the last question that we will do, and then yeah, I'll call it a day. I'll leave the worksheet down there in the description. You can give it a try, okay, yourself, and then you have all the references there, so you can always check the marking scheme. All right, so let's give this one a try. It says that solve 3 cot square plus okay, so how do we do it? You know what cot is, right? I think one of the identities that Cambridge will always give us from the beginning has something to do with cot. It gives us that cosec square theta is equal to 1 plus cot square theta, right? So if you have cos here, you can just move the 1. So you have cot square theta is basically cosec square theta minus 1. Basically, yeah, cool. So that's what we are going to do. All right, so let me just clean this part, and then later on I'll clean the other one. So that means that we have 3 into bracket cosec square theta minus 1, then 14 cosec, it's not actually theta, it's x. So why am I still writing theta? What's wrong with me? X, then this x minus 2 is equal to 0. All right, so we can now clean this guy out. We don't need it anymore. If I expand, I'm going to get 3 cosec square x minus 3, okay, minus 14 cosec x minus 2 is equal to 0. So we have 3 cosec square x minus 14 cosec x minus 5 is equal to 0. Okay, so we have something really cool like this. Now, this is something that, you can just call cosec x so that you have like 3x squared minus 14x minus 15 cos 0, minus 5 cos 0, and solve this. So this is a quadratic. I'm just going to use the calculator to do it. But Cambridge will require you to show working for that. So remember, this is YouTube. No one is going to penalize me, but you must show working for that quadratic, okay? So that is here. Okay, so I have 3, negative 14, negative 5. Calculator says cosec x should give us 5, or cosec x should give us negative 1/3. Okay, now let's continue. Now that means that, cosec is 1 over what? Sine. So we have sine x is going to give us 1 over 5. And then this will be sine x is equal to negative 3. Now, unfortunately, the sine inverse of any value more than negative 1 does not exist, because the range of sine is from negative 1 to 1. So anything more than that is not going to work. So this one, not valid. You can use the calculator to try it. Let me even try it together with you. Sine inverse of negative 3. Calculator says math error. Good. Also, change your calculator to what? Degrees. Okay, make sure that it's in degrees. All right, so then we can work with this particular one. X is equal to sine inverse of 1 over 5. So sine inverse of 1 over 5 is actually 11.5. Okay, 11.5, that's it. But you cannot say that this is the only angle, right? Go and use the cast just to check out. All right. So you have 0, you have 90, you have 180, you have 270, you have 360. Okay, the first angle you found was 11 point something. Sine is positive in this quadrant. You see, it's cast. So sine is positive in this quadrant and then in this quadrant as well, because that's for sine. So this 11.5, this will also be 11.5. All right, so if we are going 360, we meet it first here, that's the angle we wrote, and the second one we will meet it here. That'll be 180 minus 180 minus 11.5, giving us 168.5. Okay, if we continue to make a 360, we will not meet anything again. All right, so these are the two angles that we are looking for, basically. That is it. And put degrees on it, I mean, nicely like that. They said show that this gives us that. Well, it looks kind of interesting, right? Yeah, but let's see something. This is sine to the 4th power and then cos to the 4th power. But let's see something. Can't we... A 4th power is even, and then we know that sine square plus cos square also give us 1, right? So let's see. What if we do sine square y all square, right? And then minus cos, let me keep it this way and see something over cot. This is quite interesting. So I can, yeah, if I have something like that, I can split the sine, and that is 1 minus cos square y, right? Minus cos for y all over this. Okay, so if I expand this particular one, I'm going to get 1 minus 2 cos square y plus cos 4y. Oh yeah, it's good I didn't expand the other one. It's really, really good. So now we can say that this and that is 0. So that means that we have 1 minus cos square y over cot y. They want us to get tan y and then something else. So let's bring this calculation here. Okay, I need more space for that. So this is the same as 1 over cot y minus 2 cos square y over cot y. Okay, so 1 over cot y is actually tan y. Then this is 2. But check something out here. If I have cos square y over cot y, basically you have the cos square y stays. Okay, cot y is the same as 1 over cot y is the same as tan y. But tan is the same as sine over cos. So cos square y is sine y over cos y. All right? Good. So yeah, sure. So that means that we have cos square y times sine y over cos y. Now this cos will take one of this, so we have tan y minus 2 cos y sine y, and that is basically what they wanted us to show right here. Okay, good. And then is there something else to do? Oh, okay, this is another question. This is actually from where? 2020. Cool. So there's more question from 2020. I am super tired. I'm going to end here. I've been doing this for about an hour now. So give the rest a try. Solve. Compare your answers with those in the mark scheme. And I believe you should be fine. In my next video, I'm going to talk about how we transform graphs, how we sketch graphs, okay? And then everything on trigonometry should be fine for now, okay? So until we meet again, take care of yourself. Bye.